So hello everyone, today I'm going to give you a very short overview of my project titled Efficient Resource Management for 5G Enables Internet of Software as Things towards Global Connectivity. Myself, Deborsi Basu, a research scholar of IIT Kharagpur. So let's move into the topic in detail. As we all know that due to rapid digitization as this new normal due to COVID-19, everything is moving towards online. That causes a huge network traffic overshoot and causes a huge load over the network. Obviously, with the limited number of network resources, it's very difficult to provide the unlimited services to the user. So this area especially motivates us to contribute towards this field. As we all know that developing countries in India shows a very strong discrimination between metro and rural cities that shows a very severe characteristics difference in the traffic. So we propose a 5G enabled Internet of Software as Things that has a wide range of application area. So two key technology enablers here are SDN and NFV, software defined networking for flexible and programmable network, and network function virtualization for vendor independency and virtualized network. So for these two key technologies, the two key elements are here are controller, that SDN controller, and SDN hypervisor as well. So the literature survey also shows a very limited amount of contribution towards this area. So we propose mainly two works. First is the deployment of network resources to realize a flexible network architecture, followed by adaptive multi-cluster load balancing technique. So first approach will see the URLLC latency reduction, obviously 4 defined latency categorized, defining an MILP and then solving it using a greedy approach, and finally the multi-cluster load balancing using a flexible algorithm, and then we'll analyze the result. These are our network topology. We have done it over the Indian scenario. So these are the results of the deployments. Obviously, this is the main things that we finally find out the defined potential position of the network hypervisor and controller for the network flexibility. Obviously, they are dynamic in nature. They can move as per the requirement and the load. So obviously, we have received a 5.33 milliseconds of average minimum latency, and obviously maximum worst case latency is 11.66 milliseconds. That's also a minimum case. So the next work is a multi-cluster load balancing, where we consider the network as a distributed WSN wireless sensor network, and obviously these are the clusters that we have done, 3 test cases where the defined controller heads has been considered in defined metro cities. These are our flexible algorithm that solves this dynamic switch migration technique that reduce the load from one region to another. These are the test case results of defined things. So these are the capacitated controller discrimination, where this 5% threshold has been given, where the switch migration is basically taking place from the region. So obviously we almost achieve a 25% of maximum load reduction. This is for the defined test cases, and obviously for this is the maximum one we have received. So to conclude this, we know that what we are trying to do is the global connectivity, keeping the network health high. So we are coupling Internet of Things with Internet of Lives. These are our references to publication. We are also this project is approved by the TSDSI. We are currently working on it. So thank you for listening. So stay safe, stay home, and stay connected. Thank you.